Agile Quadrant 4. This quadrant concentrates on the non-functional requirements such as performance, security, stability, etc. If we know the requirements for the performance, security, interaction with other systems, and other non-functional attributes before we start coding, it is easier to design and code with that in mind. Some of these might be important than actual functionality, and some of these might require use of specialized tools and additional expertise. But with the help of this quadrant, the application is made to deliver the non-functional qualities and expected value. Types of testing in this quadrant. Non-functional testing is defined as a type of software testing to check non-functional aspects like stress testing, performance testing, usability, reliability, etc. of a software application. It is designed to test the readiness of a system as per non-functional parameters which are never addressed by functional testing. Load testing refers to the practice of modeling the expected usage of a product by simulating multiple users accessing the program simultaneously. As such, this testing is most relevant for a multi-user system like client-server model. Automation is mandatory for some efforts such as load and performance testing. Security testing can be done from two perspectives. From the inside out, which we call white box testing, and outside in, black box testing. Inside out security testing assumes that the source code for the application under testing is available to the testers. The code can be analyzed statistically with a variety of tools that try to discover common coding errors that can make the application vulnerable to attackers, such as buffer overflows or format string attacks. The fact that the tester have access to the source code of the application also means that they can map the attack surface of the application, which is the list of all the inputs and resources used by the program under test. Armed with the knowledge of the attack surface, testers can then apply a variety of techniques that attempt to break the security of the application. A very effective class of such technique is called fuzzing, and it's based on fault injection. Using this technique, the testers try to make the application fail by feeding it various types of inputs. These inputs can be carefully crafted strings using SQL injection attacks, random bit changes in a given input files, or random string fed as command line arguments. The outside-in approach is one mostly used by attackers who try to penetrate the servers or the network hosting your application. As a security tester, you need to have some mindset that attackers do, which means that you have to use your creativity and discover and exploiting vulnerabilities in your application. You also need to stay up to date with the latest security news and updates related to the platform or operating system your application runs on, which is not an easy task. Security testing falls under non-functional testing. Scalability testing verifies the application remains reliable when more users are added. What that means is, can your system handle the capacity of a growing customer base? It sounds simple, but it isn't. And it's a problem that an agile team usually cannot solve by itself. It is important to think about the whole system and not just the application itself. For example, the network is often the bottlenecks because it cannot handle the increased throughput. What about the database? Will it scale? Will the hardware you are using handle the new loads being considered? It is as simple just to add new hardware, or it's the bottleneck. Performance testing is usually done to help identify bottlenecks in the system or establish a baseline for future testing. It is also done to ensure compliance with performance goals and requirements and to help stakeholders make informed decisions related to the overall quality of the application being tested. And finally, we had load testing, which evaluates system behavior as more and more users access the system at the same time. Stress testing evaluates the robustness of the application under higher than expected loads. Will the application scale as the business grows? Characteristics such as response time can be more critical than functionality for some applications.